Hi, let's solve today's daily challenge, that is partition array for maximum sum. So in this question, we are given an integer array and we need to partition the array into contiguous subarrays of length at most k. So whatever subarrays we partition, its length cannot exceed k, right? So k is an integer that is given to us. So here in this case, k is 3. That means if I try to make partitions in this array, all the subarrays that I partition must have less than elements than k, okay, less than or equal to. Then after partitioning, each subarray has their values changed to become the maximum value of that subarray, right? So what that means that, let's say I make a partition like this, that is 115 and 7. If I make a partition like this, then this is my subarray now, and all these elements will become 15 15 15. So this is what I will get, right? So the resulting array, when I will write the subarray inside the resulting array, then it will be 15 15 15, right? So this is what basically we have to do, and what we need to calculate is the largest sum of the given array after partitioning, right? So after making such partitions in which subarray's length should be at most k, and in each subarray whatever the maximum value is inside of that subarray will become all the elements will become that maximum element only, right? So that is the question. So let's see. So we are given this question here. So what we can do is, so usually what we try to look at the problem is through the greedy approach, right? So here I can say that let's say I will only calculate the largest, second largest, third largest, and try to get as many elements as I could, right? Because first of all there is a limit, right? So that is why I can get at most k elements, right? So I'll consider, let's say here 15 is large, right? So what I will do, I will consider these three elements. So my array will become 15 15 15, and the second largest I can see is 10, right? So here I will make a partition that is surrounding three elements, and 10 10 and 10, and 9, as it is only one element, I can simply put it here. So this is kind of the resulting array that I will get. So here this gives me the answer, that is 84. But how am I supposed to know when I am using 15, right? That is the largest element. If I'm supposed to do the partition like this, because I'm saying I want to cover as many elements as I could, that is at most k elements. So I can make the partition like this, or I can also cover 3 elements like this as well, and then like this as well. Sorry, only these two possibilities are there for 15, right? So up to this, right? So how am I supposed to know which partition is the right partition for me to calculate? And here in this case, you will observe that we cannot, there is no logic, right? Greedy logic through which I can get an answer. So I have to calculate all possibilities to reach to an optimal solution. So the optimal solution is the maximum in this case, correct? So if I need to consider all possibilities, then how am I supposed to solve it? So whenever I talk about all possibilities, one thing I always have is recursion, right? So now why will we use recursion in this question? We are going to use recursion in this question because, see, we have this array, right? Let's say I take only this part of the array, only this part of the array. So what I'm going to essentially do is make some partition. So let me change the color and show you. So let's say I make the partition like this, right? And this is one subarray now, and this is the remaining array in which I can do a recursive call and calculate how am I supposed to make partitions. So I can make partitions like this, this, or this. Similarly, for one, I could have made partition like this here, or consider 115 as a subarray, or consider 115.7 as a subarray. So this is how we can make partitions, right? And thus we can see that this one array can be divided into various subarrays, and then also we can reach a solution by computing what is the maximum value for those subarrays, right? So to cover all possibilities, we can use recursion in this case. All right, now we have understood we will be using recursion, right? Now, how will we making these partitions inside of the recursion? So one thing I know is that this is an array, and with an array I always have index, right? So those index will be indicating where the partition is. Let's say I make a partition as 1 only, right? So this is 0th index. So I know from 1 index up to 6 index, I have to make a recursion call and calculate the maximum value and add to this answer, correct? Similarly, if let's make a subarray here, that is a partition here, then I have to call from, so this is 0 1, so I have to call from two index, right? So this index can help us to tell where the partition lies and what values we have to calculate, right? So I hope now you have understood how we can use recursion and how we can make partition. So now the problem is easy, right? Writing recursion is easy, not the problem. All right, so let's see, I have already drawn the recursion tree for you. So here you can see the recursion tree. So here what I'll basically do is I will be taking four variables inside of my recursion. That is, first one, I have to take an array. The second is index, as I said, it is to mark the partition. Then what is the length of the array, and this k integer, right? We have to simply take k. So these four parameters I'm going to take inside of my recursion, right? So let's say the name of my recursion function is recur. All right. So now what I will do, first thing in every recursion is the base condition. What is going to be the base condition in this case? Now what I will be doing is I will be checking for standing at each and every index, right? How many, the way the partitions can be made. So partition can be made here, partition can be made here. So at most you can see for each and every element I can consider k partition, k number of partitions, right? If I consider one, with one, either I take this one, or I take 115, or I take 115 7, correct? So these are three partitions, right? So what will happen, I have to basically check all these three partitions. So now what will be the base condition? Now let us stand at 5, right? Now if I stand at 5, I can observe that I can only make two partitions, not k partitions. So that means somewhere my index would go out of bounds, because let's say I make the partition up to here, the partition is made, and then I will make a call for next partition. Now next partition will be at index plus 1 position, right? This is index plus 1 position. Now that is out of bounds, correct? So for that we cannot afford that, correct? So what we will do, we will add this as a base condition only, that if my index, right, whatever index I get in the recursion, it should not be greater than n. That is why we have taken n here as well. So I'll simply check if ind is greater than equal to n, right? If that is the case, then I have to simply return nothing, that is 0, right? Because here from this recursion I will be returning sum, so I will return 0 here, because it is not possible to get a partition, and hence there is no remaining part of the array. So if there is no remaining part, then I can return 0 here, that is, I will not be getting any sum from there. So that is the base condition. Now we will do our recursion. Now how are we going to do the recursion? Let me remove these. So how are we making recursion here, right? What are we going to do? So as I said, we will be comparing at most k number of calls, right? Why? Because see, inside of the recursion tree, you can see what I'm doing is, what if I create a partition here? What if I create a partition like this? What if I create a partition with 3 elements? That means I am making partition k times. So I will have to loop k times, and for these 3 different remaining arrays, I have to calculate an answer based on the partition, right? So I will have a for loop which starts from I is equal to whatever the index we have here, and I should be less than index plus k, right? Because we have to go maximum. I should be we should calculate I up to ind plus k times only, right? And it will be I plus plus, right? So this for loop will be running for k times, that is, it will be helping us know the sum among k number of partitions, right? And before we use a for loop, we will declare 3 things, right? First thing would be, how are we going to calculate the sum? So we will need a sum variable here, that is sum is equal to 0. Now we know that, let's say I make a partition here, so this will be handled by recursion. What will be the remaining part of the array will be handled by recursion. Now how will I calculate the sum of the current subarray that I am at, right? The partition that I have just made, how will I calculate the sum for it? So for calculating the sum for that partition, we have to take the maximum element of that subarray, and the number of times that element appears is basically the length of that subarray, right? So what I can do is I can calculate the sum of the current subarray as whatever is the max element into the length of the array, subarray, right? Not array, subarray. So this is this plus the remaining part, right? So the remaining part will be handled by recursion only. So we'll pass it inside of the recursion and array, and the partition is made from ind plus 1. So ind plus 1 and n comma k, and this value will be compared with, let's say I am at this particular recursive call, right? So I have calculated sum for this and I have calculated sum for this, and out of these I have to calculate the maximum, right? So whatever the sum I already have, I have to compare that with the sum that I already calculated for this recursive call, the current recursive call that we are on, right? So we will calculate the sum as this, the maximum of this, right? The previous sum and whatever the sum we are considering by making current partition. So this is what we have to basically do inside of the recursion. Alright, so after that we can simply return sum from here. So what are we doing? We are taking index for making the partition, then we are adding this base condition that if my index exceeds the length of the array, then we are going out of bounds. That means there is no remaining array and I can return 0. And then we are iterating for k calls, that is we can make at most k partitions, right? So for that we are iterating so k number of times, and then we are calculating the sum for that. Correct. So this is how basically what the recursion is. So I hope you will be able to write it. I've already written the whole logic here. Now if you try to write the only recursion solution, you will be getting TLE in the question. This will result in TLE. So we have to optimize it. So let's see how we can optimize it. So here if you see the recursion tree, you can observe one thing, that is these sub problems that I have created here, these are overlapping. For example, I have 115,792 as the remaining array here. So for this particular part, I'm making a recursion call, correct? And this same part exists here as well. So this red line that you are seeing, this is the remaining array because this is the partition that I have considered, and this represents, red part represents the remaining array for which we have to make recursion calls. So you can see this is common here, right? Similarly, if you see 1,515,79, it is also common here. That is, let's say I have already calculated the answer for this, I have made the recursion for this, and now I am doing the same thing again here. Similarly, I have calculated for this and I am again going to calculate this. So that means there are overlapping subproblems, and hence I can use something called dynamic programming, so which is DP, right? So this problem can be optimized using DP. Right now, because of recursion, this is exponential time complexity, but we can optimize it. Let's see. So we have already written our recursion, right? So now it's very easy for us to write the DP as well, right? So here you can see, so now what are the steps to convert this recursion into DP? First of all, we observe how many parameters are changing. So I can see there is only one parameter that is changing, which is nothing but index, array, n and k. So array is nothing but the array that is given to us in the question, then n is the size of this array, k is the integer given to us. So these are constant. Only ind I can see is going to vary because ind is being used to create partitions. So if ind is varying, that means my DP becomes 1D DP. So we have to create a 1D array here. All right. So let's say this is the 1D array. Now what will be the size of this 1D array? So that we can check using the base condition. Now you can see the base condition is ind greater than equal to n. That means, let's say we are at nth index, right? That means we have to return 0. So I can say that dp of n, right, will be 0. So if dp of n is 0, we can see that we cannot, like, already we know that dp of n is 0. That means I don't need to consider n plus 1, n plus 2 and infinity numbers, right? Because int can go up to n plus k, right, at max. So I don't need to consider n plus k. Instead, I can simply consider n only, right? Because I know this is the base condition, right? So dp of n is 0. That means the size of the array, because n is an index, the size will be n plus 1. So from here I can see the maximum size of this dp array would be n plus 1. So that is the array that we are going to create. Now for this question, the length is 7. So dp array length would be 8. So we have 1, 2, 3, 4, 5, 6, 7 and 8 partitions. All right. Now we will fill it with 0. So we will simply write the array here so that we can make the computations easier. All right. So we have our array here. This is our dp array. Now, what does dp of I represent? So dp of I basically represents that up to see, first thing is that as we are doing recursion from backside, so that means we will be iterating from the backside inside of this dp of array and we will be forming the answer based on that, and the answer will be given by dp of 0. So dp of I basically represents that from the current index up to the right part, right, up to the right part, this particular part of the array, we have the answer at dp of I. What is the maximum sum after doing partitions in this particular part? That is from ith index to the right index, that is the ith to the end index of the array. What is the maximum answer that I'm going to get, right? So that is what we basically we will be doing. We will be starting from here, and so dp of I will be representing up to ith to the end of the array, what is the maximum sum that we can get. So I hope now dp array is clear to you, right, what it is representing. Now let us go ahead and try to see it in action, how dp of array is going to work here. All right, so here the answer is 0. Now I have 10 element here, right? Let me write the array here as well. Let me take a different pen. So I have 1, 15, 7, 9, 2, 5 and 10. So this is my array. So as I said, I'll be iterating from the back. So first element that I get is 10. So with 10, what are the partitions that I can make from this index to the right, right? So we have 10 only. So I can only make one subarray that is going to contain 10 here. So we'll have 0. So up to this particular part, I know what is the answer. So the answer is 0 here. So 0 plus 10 is nothing but 10. All right. Now what is the next element? 5. Now with 5, what are the possibilities? What are the different possibilities we have? Either I can make a partition like this, that is consider 5 and 10 different subarrays. Then what will happen? I know up to 10 what is the answer, that is 10 itself. So if I consider 5 and 10 different subarrays, then I have to add the current subarray sum, that is 5, plus up to ith index what we had, right, from ith to right what we have. So we have 10. So 10 plus 5 is 15. But wait, we have to calculate the maximum out of all these possibilities. So what is the next possibility? Next possibility is that if I consider 5, 10 as the same array, right, inside of the same subarray. So if 5, 10 are inside of the same subarray, so up to 0 I know the answer. Up to last index I know the answer, which is 0. So 0 plus the current subarray. The current subarray is 5, 10, which will become 10, 10 and give us 20, right? So 20 plus 0 will be 20 only. So I can see the maximum out of these two possibilities is 20. So I will fill at dp of this particular index 20. All right. Then we will move to the next element that we have, which is 2. So with 2, what are the different possibilities? Now with 5, 10, we don't have next element, so we cannot create k partitions. Correct. Now with 2, I can do that. So if I just consider 2 as a separate subarray, then this is my current subarray, and up to this index I have the answer. So 2 plus whatever answer I have, so that is stored in this part, that is 20. So 20 plus 2, which is nothing but 22. All right. Now I have another possibilities to consider 2, 5 in one subarray and 10 as a other subarray. So up to 10 I have already calculated answer, which is nothing but 10 only. So 10 plus the current subarray sum, which is this will become 5 and 5, which is 10, and 10 plus 10 will be 20. All right. Now, what if I consider these three elements inside of my subarray? Then what will happen? Up to here, I know the answer, which is 0. 0 plus this subarray sum. So subarray sum will be 10 into 3, right? Because 2, 5 will also become 10. So 10 into 3, 30. So 30 plus 0 will be 30, right? So I can fill this value with 30. All right. So up to this index, I am clear what is going to be the maximum value. So now let's move on to the next index, that is 9. So if I move to 9th index, I can see that if I just take 9, so 30 plus 9 will be the answer. So let me write here 39. Then if I consider 9 and 2 as one subarray, so up to 5 I know the answer. So up to 5, what is the answer? 20. So 20 plus 18, which is nothing but 38. All right. Then if I consider 9, 2 and 5 as one subarray, so up to 10 I know the answer. What is the answer? 10. So 10 plus 27, which is going to be 37. So here the maximum out of all these possibilities is 39. All right. So after doing this, we will move on to the next element. Next element is 7, right? 7 here, right? So with 7, again, 3 possibilities I have. So k number of possibilities we will have for each and every number. We have 7 and 7. If I just consider 7, right? So up to 9 I know. So 39 plus 7. 39 plus 7 is nothing but 46, right? So I will get 46. Then if I consider 7 and 9 together, so up to 2 I know the answer, that is 30. So 30 plus 18, which is nothing but 48. Then if I consider 7, 9 and 2 as a subarray, this part, then what will happen? Up to 5 I know the answer, which is 20. So 20 plus this will become 999. 27 plus 20, which is nothing but 47. So out of these possibilities, 48 is the maximum. So I'll put it inside of my DP array. After that, what will happen? After that, we will come to 15, right? If we come to 15, if I just consider 15, right? So 15 plus up to 7, what is the sum? 48. So 15 plus 48 is what? 63, right? It is nothing but 63. All right. Now, if I consider 15 and 7 as one subarray, so up to 9 I know the answer. What is that? 39. So 39 plus 30, which is nothing but 69. All right. Now, if I consider 15, 7 and 9 as a subarray, this part, so up to 2 I know the answer. What is up to 2? 30. So 30 plus 15, 15, 15, that is 15 into 3, 45 plus 30, which will give us 75. So we'll put 75 here. All right. Now after, we will move to the next element, which is nothing but 1. So if I take 1 and as a separate subarray, what will happen? 1 plus 75, that is nothing but 76. Now if I take 1 and 15 as a subarray, so up to 7 I know the answer. What is it? 48. And 48 plus 30 will do. So which is nothing but 78. Right? Now if I take these three elements, that is 115, 7. So up to here, I know the answer, that is 39. And 15, 15, 15. So 45 plus 39 is nothing but 84. Right? So here we will get 84. So this is how basically the DP array will be built after tabulation, right? After memoization or tabulation. Here we will be writing a tabulation approach, and this is the tabulation approach only. So this is how our DP array will be filled, and the answer will be DP of 0, as you can see from here as well, right? So now I hope it is clear how we will basically be doing this question. Now let us go ahead and code it. All right. So first thing first, I have to take the size of the array, that is int n is equal to array dot size. Then we'll declare the DP array. So as we discussed, the DP array size would be n plus 1, and DP of n is nothing but 0, and that is already done here. But to write the base condition, to show you the base condition, I've just written it here. Then what we have to do? Then we have to iterate. From where do I have to iterate? From the back side of the array, that is from right to left I have to go. So I'll just write that int I is equal to n minus 1, I greater than equal to 0, and I minus minus. Now after that, what I have to do? I have to take this I, and from this I have to make partitions, right? How I have to make partitions? So let's say if I was standing at 7, then what I did, I considered this then I consider 7 9, then I consider 7 2. So we are basically moving from left to right to consider the subarray. So for that we'll write, and before that I will initialize 3 elements here, that is the max element, the length of the subarray, and the sum, right, which will be helping us to know the maximum sum out of the all of the possibilities. All right, so we'll first do int max element. So basically we do not have negative numbers, so I can simply take it as 0 instead of int min, take sum as 0 as well, and then len, which I will take taking as 1. All right, then I have to iterate in another loop, which will be int j. Now int j will be starting from that particular index, that is I, right? So I'll start from I, and j have to go up to less than ind plus k, correct? That is I, that is the index plus k. So I'll write ind plus k. But to make sure that this ind plus k don't go out of bounds, because at most I know that I can have k partitions, but in some cases where I am less than k numbers behind from the right side of the array, so I can go out of bounds, because then I will not have k number of possibilities, right? So here I can simply put it here like this, and I can say minimum of index plus k comma, and so we don't go out of bounds of the array. Then what we'll do j plus plus, and then we have to now compute the values. All right, so now how am I supposed to know the value, right? So first of all, I need to know what is the max element. So max element is going to be the maximum of the max element that we already have and the current element, so that will be array of j. All right, then I have to calculate the sum. So sum will be maximum of sum comma, one thing is sure, that maximum of element, correct? And then plus, what do we have to add? We have to add that in recursion we saw that we have to add ind plus 1, that is we are making the partition. So here that simply becomes dp of j plus 1. All right, so that is what we are calculating, and then I have to simply do len plus plus to increase the length of the subarray, because in the next iteration it will be increased, right? So this is basically, okay, max element into length I have to do, right? Because number of what is the length of the subarray, that is the number of elements, into what is the maximum element of that subarray. So that I have done, and after this for loop I can simply know that is sum is going to contain the maximum, and I can put it inside of my dp array to be used for next iterations, right? So dp of I now will become equal to sum. So after this for loop, as I know, the answer for the final answer would be stored at dp of 0, as we saw. So I can simply return dp of 0 here. So let's quickly run this code to see if it works. Okay, there is some error. Oh, all right. This is not ind but I, right? All right, so it's accepted. So basically this is how we have to solve this question.